Cybersecurity in the industrial environment. Protection of the OT area. Bastioned facilities. Media redundancy. Having redundant equipment is a good way to ensure availability when one of them fails. The MRP ring is probably one of the most widely used redundant systems. In the context of network management, redundancy refers to the inclusion of additional components in the network that provide backups or alternate paths to ensure that the network continues to function in the event of failures. Implementing redundancies in a network is a good practice to ensure the availability and reliability of the network. Some examples of redundancies in computer networks may include link redundancy. This refers to the inclusion of multiple physical paths between devices on the network. If a link fails, the network can automatically switch to a backup path to maintain connectivity. Equipment redundancy. This refers to the inclusion of additional devices on the network that provide backups in the event of a device failing. For example, additional switches may be included to ensure that a switch is always available in the event of failures. Power redundancy. This refers to the inclusion of redundant power supplies or backup power systems, such as batteries, to ensure that the network continues to function in the event of a power outage. Implementing redundancies in a network can be expensive, but it is an important investment to ensure network availability and reliability. Costs associated with implementing redundancies can include purchasing additional equipment, using redundant power supplies, and setting up backup power systems. However, the benefits of redundancy in terms of network availability and reliability can far outweigh the implementation costs. RSTP is a fast spanning tree protocol used to prevent feedback loops and improve network recovery time in the event of a link failure. RSTP allows redundant links to remain active, but automatically deactivates the redundant path in the event of a link failure. MSTP is a spanning tree protocol that allows multiple spanning tree instances to be created on a network and multiple VLANs to be grouped into a single spanning tree. MSTP is an enhancement to RSTP and allows devices on the network to use different paths for different VLANs. PRP is a protocol that uses two independent networks in parallel to ensure continuous network availability in the event of a link failure. PRP uses a technique known as traffic forking to ensure that each redundant link receives only one copy of the traffic. MSTP is a spanning tree protocol that allows multiple spanning tree instances to be created on a network and multiple VLANs to be grouped into a single spanning tree. MSTP is an enhancement to RSTP and allows devices on the network to use different paths for different VLANs. The PRP protocol is a protocol that uses two independent networks in parallel to ensure continuous network availability in the event of a link failure. PRP uses a technique known as traffic forking to ensure that each redundant link receives only one copy of the traffic. HSR is a ring protocol used to provide fast, lossless data switching in the event of a link failure. HSR is a Layer 2 protocol that uses two independent rings to transmit data in both directions. The MRP protocol is a media redundancy protocol used in industrial networks to provide high availability and link redundancy in case of failure of one of the communication links. An MRP ring can be considered as an aggregation layer as it acts as an aggregation layer in the industrial network by providing high-speed connectivity and redundancy between access devices and core devices. In addition, the MRP ring can also perform functions such as link aggregation, load balancing, and fault detection, making it an effective aggregation layer for industrial networks. The MRP protocol is an open standard, which is specified in the IEC 62439-2 standard. It can be used with various communication media such as fiber optic rings, copper rings, wireless networks, and other media. MRP works by creating a communication ring between devices on the network. The devices are connected in a logical ring instead of a physical ring, which means that the devices can be connected in any topology that fits the application requirements. MRP uses two types of devices, a primary node and a secondary node. The primary node is the device that controls the communication ring and is responsible for selecting the appropriate communication path. The secondary node is a backup device that is activated in case of failure of the primary node. When a failure occurs on the ring, MRP detects the failure and the secondary node is automatically activated to restore the connection. The recovery process is fast and no data loss occurs. In addition, the MRP protocol supports the integration of multiple redundant rings, providing a higher level of redundancy in the event of a failure of the main ring. In an MRP ring, connected devices take on the role of either manager or client. Managed switches can have both roles. Decentralized peripherals can only be clients. PLCs can have both roles. HMI panels can only be clients. Some features of MRP rings. All devices connected to an MRP ring must support the MRP protocol and have it activated. Each ring must include at least one MRP manager. Connection between devices can only be made through the ring ports. Response times are less than 200 milliseconds for rings with a maximum number of 50 connected devices. During operation, the manager sends test telegrams in parallel to both stations and they must be received by both. If the manager does not receive any of the test telegrams back, for example due to a cable break, then the manager switches the redundant line from passive to active.